Okay, so sorry for the slightly abortive start. I am Ben Pirt. I'm a principal technologist at a company called Meetup. We work in across UK government, and I'm particularly focused on the Ministry of Justice, which is where I've been working for the last sort of 5 or so years. I specialize in modernizing legacy systems, which is for me a lot more fun than it sounds. But I'm going to talk a bit about a project that I've been working on for the past few years and how we've approached it and how that involves Conductor. So first of all, Ministry of Justice. It's responsible for criminal justice in the UK, as you might guess from the name. Um, it's got a lot of tech to manage. So its GitHub account has over 3,000 repositories. There's a lot of other other code as well, but there's quite a large in-house developer team. There's just a lot of stuff going on. It's a very large organization. I've been working in a sort of microcosm of the Ministry of Justice on a system called Bichard 7. So to kind of set the context of what I'm going to sort of go into, it's worth me just sort of giving you a bit of background on this. So aside from having a sort of 15 to 20-year-old interface that makes your eyes bleed, it's the system that is a mission critical piece of infrastructure for the UK. It transfers court results from the court systems into the Police National Computer, or PNC. It exists because in 2002 there were some murders that were relatively well known in the UK, SOA murders, and they happened because the data on the PNC was out of date with what the courts said should happen to a person. And so the investigation by Lord Bichard, the seventh recommendation was that there should be a system that transferred automatically the results from the courts to the PNC. IBM built it originally. We've spent the last sort of 3 or so years modernizing that system from the kind of older IBM stack technologies to more modern cloud native ones. We've moved it into AWS, and we're now getting into reworking the core business logic that's kind of rotted over time. The original spec for the system is kind of lost in the mists of time, and now the spec is as is often the case in many old systems, is what it currently does is the spec for what it should do. So we've been using quite a lot of different techniques to make sure that our changes don't break things. I'm not going to talk about those today, but there's some quite big challenges to make sure that we don't break this, because as I say, it's a mission critical system. So what it does, it's quite simple, really. The diagrams get gradually more complex, but we receive a message from the court for every court result. So if there's a verdict, guilty, innocent, sentencing, released on bail, those kinds of things, we get a message. It's a pretty antiquated, horrible XML message, but it's a message. We validate that message. We make sure that all the data makes sense, and we cross-check it against what's already in the police computer to make sure that it's able to be sent there. And in about 85% of the times, we are able to add that court result into the PNC. The other 15% of the times, an officer will have to fix the data, and that might be because the records from the court don't quite match what's in the PNC, and so we're quite cautious. We make sure that we only act on the kind of correct data. So we flag it up for a police officer, to manually resolve it, and they will then resubmit it and try and get it into PNC. And worst case, they'll end up doing it manually, which happens far more often than it should do. But that's the state of government data. It's made up, as we've kind of gradually been modernizing the system. It started off as one large monolith, one very large enterprise Java code base that was incredibly convoluted to understand. We've broken that up into lots of kind of different interrelated systems. So we've still got the core logic, which is still in the enterprise Java sort of world, but we've sort of split out things like the UI as a separate service, the audit logging as a separate service, and an API around the PNC, reporting, all of these kind of things. break out into the sort of microservices that a lot of modern tech uses. It's interesting actually with legacy modernization. Um, I've kind of got an observation, which is that whenever you're modernizing any kind of legacy system, you go through this sort of pain of things have to get worse before they can get better again. And so we're probably at the kind of peak pain point now where we've taken this relatively neat monolith, but neat but unmaintainable and very very hard to work with monolith, broken it up into lots of systems, and we've kind of shifted that complexity into the network now, and now we're at a point where we can start to consolidate back together and reduce the pain. It's quite a long journey, as I say. We've been doing this for the last 3 years or so, and we've got more years to come. But yeah, it should end up in a really positive place. So first observation, really, I mean, is managing complexity in any kind of distributed application is really hard, but it's hard in lots of different ways. So we found it's very hard for a developer team to actually understand how that application works when everything is split into different components and sort of workflows and systems. It's really hard to understand the sort of state of processing of a particular message at any point in time. So we receive messages from the courts. They could be in quite a few different states on the way to going to the PNC. So it could have just gone straight into the PNC and be finished. It could have raised exceptions and be waiting for a police officer to sort those out. But it's really hard to actually pinpoint exactly where the processing of a message is for a particular incoming message. And we spent quite a long time kind of almost reverse engineering from the audit logs what the state of a message was, and that kind of taught us just how hard it was to get a really concrete view of processing state. The other thing is that the more components you have, the harder it is for that dev team to really understand the big picture of what the application does. They might end up working on a small part, and if you're not careful, the gaps between the systems become quite a major point of failure. So lots of sort of loosely coupled, decoupled systems is fine in principle, but it can become hard to model them, and it can become hard to guarantee that changes to one of these decoupled systems doesn't unwittingly affect another without adding lots and lots of end-to-end tests, which we do have, but it's again adds to the complexity of running an application like this. So yeah, loosely coupled services, great. Services that don't know about each other, it makes a lot of sense. But eventually, if you want to avoid the kind of insanity that comes with like massively distributed systems, you do need some kind of layer to unify them. So for example, and this is something I've seen happen. You might end up testing components of the system by mocking inputs, and everything seems fine. And then you realize that your mocks are out of date and someone's changed something in another system. And when you actually deploy everything to production, even though the tests all pass, because the mocks are out of date, when it hits production, things fail. We do have lots of end-to-end tests to protect against this, but the mistakes can still happen, and there are always gaps in tests. So yeah, you got to make sure that the contracts between the different services remain very consistent, and yeah, that end-to-end testing, you end up focusing a lot of your attention onto that. So this is where we found Conductor can help us quite a lot. It provides the sort of glue between a lot of the services that we have. That means we can model full workflows rather than just relying on the sort of individual systems to operate independently. We looked at lots of different systems and tried a few out with varying degrees of success, but eventually settled on Conductor. One of the things is because it's open source, and for those who aren't aware of sort of government IT in the UK, there's quite a big push for open source systems, which is very good in my book. It's an important part of kind of open government is that open source. It's also healthy, so it's also nice to have seen that RPRs have been merged. But I think also really importantly was that when we looked at these systems, we found that Conductor was actually understandable. you could actually understand the architecture of it. Whereas some of the other systems we looked at were vastly more complex. So that's a lot of kind of intro. So I'm an engineer, so I'm going to get into the kind of real world examples and show you some of the things we've been doing. So again, diving into Bichard a bit more. It's not actually massively complex. It may look slightly complex depending on what you're used to. But it starts here. Messages come into S3 in AWS. They get processed by a kind of incoming message handler, we call it, that logs the fact that we received it and sends it into message queue. It goes in and out of the message queue, in and out of different phases of processing. It might end up in the database to be processed in the UI and loop back around into the message queues. But broadly speaking, that's the kind of main architecture. There's some audit logging off to one side via message queue as well. And eventually it should end up in the police national computer. So that's all well and good. You know, it's a kind of diagram you can follow the flow through. However, given that each of these systems is sort of decoupled from each other with message queues, the diagram probably looks actually more like this. So each of these individual systems is kind of extracted from the previous diagram, but none of them really know about each other, although they use sort of contracts between each other to sort of send messages between the message queues and from one of the parts of processing into an API and things like that. They're all very separate, and yeah, as I mentioned earlier, one of the things that means is that it's often very difficult to work out exactly where a message is in the processing flow at any one time. It's not impossible, and we have spent quite a lot of time building in functionality to let us sort of see that. Yeah, and the observability, is the kind of big thing there. Is we have built that, but it took a lot of effort. And it definitely wasn't as easy as it should have been. And that's because there's no overarching system tracking the state of a court result moving through the system. So yeah, maintaining a mental model of a distributed system is hard, and it's particularly hard for new team members because you're never really looking at the big picture. It's almost impossible to understand the full impact of any changes you're making, and you end up relying a lot on end-to-end tests. Now, that's not to say you shouldn't have end-to-end tests. I'm a big believer in quite a comprehensive test suite, but yeah, if you're not careful and if you don't have those tests fully fleshed out, you can change the contract of one of the parts of the system without realizing that another part relies upon it. So yeah, we found that Conductor helps us turn these isolated, decoupled systems back into a more coherent whole. Right, real world example, modeling all the things. So we have a need to report errors. So sometimes we get messages from the courts that have invalid data in them or invalid structure, very rarely. But if that does happen, because it's a mission critical system and it's there to kind of prevent loss of life in the worst case scenario, we need to let the courts know that we weren't able to process this message that they sent, so that they can either handle it manually, let the police know, directly, or some kind of manual process that sort of goes around the sides of Bichard. So what we did previously, the message would come into the message queue. We'd receive the message. We'd pass the message. It might fail to pass, and if it did, we would log that failure to the audit log into the audit log API. And then in another completely separate process on a cron job, we would retrieve records from the audit log API, generate a report if there were failures, and then send that report off to the upstream system, which is called Common Platform. But it means that these two completely separate things, people actually, this always astounded me. People didn't know some of them were there, so people would focus on the core happy path of the system, and some developers were sometimes oblivious about the fact that there was this common platform report that got sent twice daily, and it was very easy. We had to be very careful when we did a big refactor of the audit logging to make the messages sort of more consistent, because we kind of inherited them all as we took over the system. We wanted to then sort of bring them all in line. I think they'd gradually evolved, and it would have been extremely easy to just change the structure of the audit log message that we were writing and then unwittingly break the report without knowing that that report relied on a specific format. So what we do with Conductor now is we model it as an explicit part of the main processing flow. So you can see here, this is actually an extract from a screenshot of Conductor itself. We do some conversion, we create some audit logs. We then check to see if the parsing failed. And if it did, we log that, the audit log, because we like lots of audit logs because it's an important system. And then we alert common platform, and that just sends off a message to them to let them know. And whilst this isn't revolutionary, what's been amazing for us about this is that it's put this previously quite hidden part of the workflow, which was an explicit part of the workflow, but it was hidden away. It's made it sort of front and center part of the main UI, so that any developer who's looking at what we're actually doing with Bichard will look at this and go, I see. Yeah, we checked to see if the parsing failed, and if it did, we sent an alert to common platform. Right, it's there. It's front and center. And I think that's one of the big things for me about Conductor is that it's kind of self-documenting. The fact that you get a diagram for your workflow means that other people can look at what's going on and actually understand the processing flow. So another example. So when I said modeling older things, that obviously also includes tasks performed by humans. Now, previously, when people were processing messages, I'll come. There's a diagram following this. I'm jumping ahead of my own slideshow. So when I said about 15% of the time there were errors in the data and the police needed to manually resolve those, they can fix the data and resubmit. So the message goes to the UI, they fix it, it goes back into the pipeline and then gets processed by Bichard. So you can see here, message comes in, the message queue, gets processed, we detect a validation error, we write it to the database. And then the user then loads the interface, they can see that record, they fix the data, they resubmit the message, it goes back into the message queue, comes back out, and effectively, goes around in a sort of figure eight until it's done and completed. But again, it's very difficult to know when a message was complete because it's hard to sort of track the state of that without explicitly creating a sort of system to track it. It's hard to know sort of how many times it had been resubmitted, exactly what the officer had done without, we relied a lot on our audit logging to be able to look at the sort of events of what had happened on that without, and that kind of doesn't really give you the explicit state at any one point in time. It relies on you being able to interpret the audit logs rather than showing you exactly where some things are. So with Conductor, what we did was we modeled this in a loop. So we run the processing, store some audit log events. We check to see if there are exceptions generated. And then at this point that's highlighted in orange, we wait for resubmission. And this is a human task. At this point, at some point, the user will then load the record in the UI. They will fix some data, and then they will click resubmit. And what happens now is this human task gets marked as complete. And then we read that record again, read the updated record, and loop back around and reprocess it. And so what was previously two separate systems that would loop to each other, but you wouldn't really have any kind of understanding of the fact that these were looping around, now becomes explicitly modeled so that you can see that we're still sort of stuck in this loop, waiting to see whether it's been resubmitted successfully and then gone around and been processed and eventually gone to phase 2, which is the next bit that we're doing. Again, it gives you a really clear view of the state of the application and the processing of a particular message. Modeling that human action as an explicit event in the workflow was a real breakthrough. we actually started off by kind of mirroring our existing architecture with Conductor. So we had multiple workflows, each of which were kind of decoupled via either message queues or S3 buckets to kick them off, and they didn't really know about each other. And it wasn't until I realized the kind of or kind of grasped the concept of modeling the whole business workflow, um, that I think the power of that of the sort of observability that comes about as part of that with Conductor is apparent. By kind of putting everything into Conductor to sort of embracing the Conductor way, I think it gives you massive benefits in terms of the observability of your system. So yeah, that's the big takeaway for me was to model things in a way that actually represents business processes rather than using it as just one tool in the system. It's a incredibly powerful tool to be able to see your actual business workflow represented on screen and be able to see at any point in time where the processing is at that in that system. Yeah, the big benefits really observability for me is key. We can actually see what's going on with the system and be able to, you know, interrogate exactly what happened in a particular task, see the inputs and the outputs, and it's kind of like being able to debug, run a debugger after the fact. But that full system understanding, being able to model the full end-to-end workflow is incredibly powerful. I haven't really touched on robustness, but that's another big win for us in that. And it's quite interesting because we're moving from a legacy enterprise Java system, which actually one of the things that does really well is deal with distributed transactions. When you're moving to kind of microservices world, you know, what do you do if one of your non-transactional endpoints fails? So, let's say we're audit logging something to one HTTP API, and then we're doing something else to another HTTP API. One of those fails, and how do you deal with rollbacks and things like that? You can't. And so by breaking the workflow up so that we only do one kind of transactional operation in a step means that we get all the retries without having to worry about the rollbacks that often that causes so much pain. That's it from me. So yeah, any questions? I think Olivia was saying that the Q&A is the place.
Thank you, Ben. So interesting to see not only an explanation about the features, but explanation about real case and how the features of Conductor are used. Thank you so much for that. So yeah, we have a couple of questions, and the first one is about the migration process and how Conductor helped you in the migration process. Meaning, like, I mean, we saw in your presentation that it's a very strategic application, and you had to manage a switchover. How Conductor helped you in this process?
So I think yeah, the actual act of migration. I think the thing that's helped us really is having a lot of tests around the system. So we've been able to we've got a lot of end-to-end tests that test out different facets of the system, and we're able to switch out Conductor for the legacy Java system and run the same tests end to end and see that the same things happen on all of the inputs and outputs. And that's given us quite a lot of confidence that the changes that we've made by porting things into Conductor haven't affected the actual overall behavior. One of the things we've done, which is non-Conductor specific, but it's been quite an interesting approach, is for the last sort of 14 months, we've been recording all of the inputs and outputs of the first stage of processing of Bichard. So every message that comes in, we log the input data, and then we log exactly what the output data was from that message processing. And when we've rewritten that back end to port it into Conductor, we've been able to run those same sort of comparison files through and validate that the behavior of our new code matches exactly the behavior of the old code. And so yeah, that's a tool we've used, and that yeah, so we've got a few million records that we can play through, and we use Conductor to run that kind of parallel operation to replay all of those millions of records and validate that the behavior is identical to what it was before.
Amazing. One last question before we switch to the next speaker. Any guideline or good practices you can give to the audience on how to approach a new system with Conductor from a developer point
Yeah,
of
so
view?
I think the big thing I would say about Conductor is around the I mentioned it at the end there, the sort of transaction sort of handling transactions, particularly and it's particularly useful in sort of modern applications where you do have often kind of HTTP APIs that you're integrating with. So let's say you've got a user service, an application comes in, it handles your business workflow handles that application for a new user account. Conductor can then go and create that user account in one API, log the fact you've created it to another API, set up something else in another API. And if one of those APIs fails, that step can be retried individually rather than if you're trying to, yeah, it sounds like quite an easy problem, but then if you were to do that in one script, then and the middle one failed, what would you do about the first one? You've already created the account. Do you just not log it? It's a really messy problem, and I think I sort of this kind of design pattern of doing a sort of single write transaction in any one step is quite a good one to bear in mind for that.